Sometimes we have to look at the equation and move terms around before we can even start solving anything. So in number 35, you'll notice that we have a negative 7k squared on the right side of the equal sign. So if we just get rid of that 7k squared over there by adding 7k squared on both sides, you'll find that we end up with k squared plus 5k plus 4 equals 0. Now this one is easy enough to factor because we can identify the factors of 4 as being 1 and 4 and 2 and 2. Now again, it's a positive, so the two factors have to add up to be the same as the center term, which is 5. So the factors that we have to use are 1 and 4, or the numbers that we have to use are 1 and 4. So we need a k and a k to give us the k squared, and because the center term is positive, we're going to have a positive 1 and a positive 4, and so when we distribute those back together, we would end up with k squared plus 5k plus 4. So we have the right factors. Now we simply set these equal to 0, and so we have k equals negative 1 and k equals negative 4. Okay, so that's the simple case. What's not so simple is something like number 37. Okay, so in number 37, we need to get everything on the left-hand side, so we're going to subtract 64 and we're going to subtract 16n. So we end up with 3n squared minus 16n minus 64 equals 0. Okay, so now we're stuck with this particular problem. So the first thing we always want to check is, can we divide out whatever a is? So a is 3 in this case. Does 3 go into 16 evenly? No, it does not. So we can't divide out the 3. So this is going to force us to have to do what's called grouping. So in grouping, it takes a few steps, and it seems a little complicated, but we actually are working the problem very similarly to what we had done before. The one odd thing that we have to do is we have to multiply our A times our C to get a new number that we're going to factor. So 3 times 64 is 192. Okay, so just like we saw before, we need to find factors, and because this is a negative, we have to find factors that subtract to be 16. So factors of 192 that subtract from one another to equal 16. So it takes a little bit of time to write out the factors, but once you get to the factor that subtracts to get 16, you can stop, and 8 minus 24 will give us a negative 16. So that's what we want to stop at with our factors, and now we can continue on with our problem. So we're going to rewrite our equation so that we can put in these new factors, but the 3n squared is going to stay there. And we have our negative 64, it's going to stay there. What's going to change is the inside, because we need to situate our 8 and our 24 so that we can this is called grouping, so that we can group our 3n squared with a number that makes sense and our 64 with a number that makes sense. Now when I look at my 8 and 3 have nothing in common. But when I look at my 8 and 64, they do have something in common. So I'm going to put a plus 8n here. My 24 has something in common with 3, so I'm going to put my negative 24n there. So now I haven't changed this equation, I've just rewritten it, because it's still equal to this equation here. It's just I broke the negative 16n into two components that have something similar to the other two numbers. So now I can group this these two terms together, and I can group these two terms together, and I can factor something out of each of those two terms. So let me do that real quick. So these two terms we're going to keep together, and these two terms. So when we look at 3n squared minus 24n, we can factor out a 3n. And what's left, when we factor out 3n from 3n squared, we're left with n. So what I mean by factor out is we're dividing out a 3n. So 3n squared divided by 3n gets me n. Now we have 24n, and we're going to divide out 3n. And so the n's divide out, and the 24 divides with 3, and we have 8. So we're left with a negative 8. Over here in this set of terms, we're going to factor out something that's common, and that what's common between the 8n and the negative 64 is a positive 8. So we're going to factor out a positive 8, and so 8n divided by 8 just leaves me with n. And then we have 64, negative 64, divided by 8 leaves me a negative 8. So I have a negative 8 here, all equal to 0. So I've rewritten my equation to make it a little easier to see. So now I have 3n times n minus h plus 8 times n minus 8, not h, equals 0. So now I have a term here and a term here, because terms are separated by a plus or a minus. So I have two terms, and something common in each term is the n minus 8. So I'm going to factor out or divide out an n minus 8. So I have n minus 8, and what I have left over here is a 3n. When I divide out n minus 8 over here, I'm left with the plus 8. And that all equals 0. So now I have my two factors, one factor there and another factor here. Now remember, we're solving for the value of n, so we can set each factor equal to 0. So n minus 8, when we set it equal to 0, we add 8 to both sides, and we just get n equals 8. On this side, we set that equal to 0, so we have 3n plus 8 equals 0, so we have to subtract 8 from both sides. That leaves us with 3n equals negative 8, but then we have to divide by 3 to get n by itself, so we have n equals negative 8 divided by 3. So our final two answers, our two solutions to this problem, is n equals negative 8/3 and 8. Okay, that looked like it was a really difficult problem to do, but let's do another one, and maybe we can get ourselves to where we understand how to do this. So we need to move all the terms to the left-hand side. So I'm going to subtract 41n, and I'm going to add 30 so that I can get it off of the right side, and now everything's on the left side. Okay, so the first step, we multiply a times c, and we get 210. Then we're going to find the factors of 210, and again this time we have to add them together so that they equal 41. Okay, so we're going to create the factors of 210 and find the factors that add together to equal 41. So once we get to the factors that when added together give you 41, we can stop. So 6 plus 35 gives us 41. So now we're going to use these two numbers and rewrite our equation, again keeping the first term, and we're going to keep the last term, and we still have all of that equal to 0. And we're going to take our 6 and our 35 and line them up with the numbers that we currently have. So 6 and 7 don't have anything in common, so we're going to put the 6n with the 30n, and remember, or 30 rather, and we have to have a negative with that because they're they are going to create a negative 41. The 35 and the 7 have something in common, so we're going to put the negative 35n with that, or close to that, so that we can group those two together. Now recognize that negative 35n minus 6n gives us negative 41n, so we haven't changed the equation, we've just rewritten it to a different form so that we can group these two terms together and then these two terms together. So when we factor something out of the first two terms, the 7n squared minus 35n, the thing that's common in both of those terms is a 7n. So when we take 7n squared and we divide it by 7n, the 7's divide out, and the n divides with one n, and therefore we're left with an n. When we take 35n and we divide out 7n, the n's divide out, and 35 divides by 7 to be 5. So we have a negative 5 there. Now in the second set, we're going to divide out a negative 6, and so we'll have n minus 5. And all of that, again, is equal to 0. Now we can rewrite this equation so that we can see how to factor from there. So I'm just rewriting it because there's some information written just above here. So we want to factor out something that's common between this term and this term. Remember, terms are separated by either a plus or a minus, and that's what's happened here. They're separated by a minus sign. And so we have 7n times n minus 5 minus 6 times n minus 5. So the thing that's common is the n minus 5. So we're going to factor out n minus 5, and what's left in the first term is a 7n. And when we factor out an n minus 5 in the second term, of course when I say factor out, I mean divide out. When we divide negative 6 times n minus 5 by n minus 5, we're just left with a negative 6, and all that equals 0. Finally, we set each one of these factors equal to 0 to find out what n equals. So when n minus 5 is equal to 0, we know that n equals 5. When 7n minus 6 equals 0, we have to add 6 to both sides, and we have 7n equals 6, and then we're simply going to divide by 7, so we have n equals 6/7. So our two solutions to this problem are n equals 6/7 and 5. I hope this helps you to work some of the other problems. So I'm going to show you a few more to let you work them on your own and then give you the solutions. Okay, so write these two problems down, 42 and 44, and pause the video, do the work, resume it, and the work will be done for you so that you can check your answers. Here's the work to both of those problems. You'll notice that 42 has the answer a equals negative 1/3 and a equals negative 2/3. And for number 44, b equals negative 7/6 and b equals 7. Hope you got them right.